When Fox released the original DSC compression adjuster, it was absolutely game-changing. It was the first high and low speed compression adjuster widely adopted by the off-road industry. But time has changed, things have advanced, and now Fox has released the new DSC Evo compression adjuster, and today we're going to see if it stacks up. The Fox DSC Evo is using Fox's VVC technology, which stands for variable valve control. This technology first appeared in mountain bike shocks and has since been adapted over to power sports and motorsports and off-road. And so there's quite a bit of history behind this design, and it clearly has a lot of really good engineering work put into it. On the Fox Power Sports side, which is all the UTVs and things like that, they use a standardized piggyback bore diameter, and I believe that this is probably using that same bore size, which could allow them to make an electronic version down the road. Let's take a look at the external differences between the two designs. The DSC here is kind of the original standard. It has a pretty compact design, and as you can see, the DSC Evo is quite a bit larger. That's probably more a problem for the engineers that have to fit this on a vehicle, but it's worth noting. Some of the complaints that we hear about the original DSC is that the low speed knob here is really hard to feel the detents, and on the high speed knob it can be quite difficult to adjust. Fox has done a great job on the new DSC Evo, really improving the detent feel on both high and low speed. The clicks are really pronounced and easier to feel. The force to turn the high speed knob on the new DSC Evo is much softer, so it's easier to turn. And then also they've done a better job of refining the design to be easier to use on the hand. And so the kind of clicking sensation and user feedback on the DSC Evo is much better compared to the original DSC. Another nice thing that Fox has done on the DSC Evo is they've gone and labeled all the different settings so that you can tell which click you're on. This is really nice. Currently these shocks are only available for the 24 Tacoma, and unfortunately once they're installed we weren't actually able to see the numbers, but on some applications you probably will be able to, and it is definitely a nice feature to have. When it comes to the number of clicks, the Fox original DSC has 10 clicks of low speed and 12 clicks of high speed adjustment. The new DSC Evo has 7 clicks of low speed and 7 clicks of high speed. I wouldn't get too hung up on those numbers. As long as each adjustment click is providing a reasonable amount of adjustment, those are both a reasonable number of clicks to have. If we wrap this up, overall, the external appearance here of the two adjusters, the original DSC was a little bit more compact, but with the new DSC Evo, they've done a great job of really improving the feel of each click and the detents. And so overall, when it comes to external appearance, the new DSC is definitely an advantage. So we've got both adjusters disassembled here, so we can show you kind of the basics of the flow path and how they're working. And so first we'll start with the original adjuster here. And so the oil is going to come in through the hose, and then once it comes in through the hose, it's going to make a hard 90-degree turn, and it's going to be, oil will be in this chamber here. And the first flow path option for it on low speed movements, small amount of oil, is there's a needle and seat in here, and it can go through that needle and seat and just kind of flow freely through. And then as the quantity of oil and the speed of the oil increases, then the oil is going to have to go through this piston here. And so this piston has got 6 holes in it, and this digressive plate here sits and covers those holes. And then on this plate is the shim stack. And so for the oil to flow through the piston, it's got to bend these shims. And then these shims are retained by this nut, which is threaded on that shaft I showed you earlier. And then we have this cross pin here, and this cross pin is holding the nut from rotating. So that's the basics of how the DSC works and the basics of the flow paths. Over here we've got the DSC Evo disassembled. So this is the housing here, and the flow path on it, the oil comes in through the hose right here, and then there's a little bit of a diagonal hole down here at the bottom. And so then the oil is going to go in through that hole, and it's going to come back up this way, and this adjuster mechanism is down in there. And so the oil can either flow through the low speed circuit if the oil's moving slowly, and that's the hole here. Or if the oil is moving quickly, there's a lot of oil, then it's got to go through this piston here, which is backed by a couple of sets of valve shims, and we'll get a little bit more into that later. And then once the oil's gone through the adjuster mechanism, it's going to go back down and around. There's 6 more holes in here, and those holes come out down here. So the oil flow on the DSC Evo is again down through here, up through the adjuster mechanism, and then back down and around. And that's kind of why we said earlier we think this was an adjuster that was made originally for a piggyback shock, where the oil was kind of coming straight at it and then down into the reservoir. So now when it's used in a reservoir situation, the oil flow is a little bit more convoluted, and that's why this housing's gotten so big. So that's basically the summary of the oil flow and how the oil's moving around inside the adjuster, and it helps kind of explain the sizing of the different parts here. And so hopefully you found that useful. Now we're going to review the low speed compression adjuster circuit on both these adjusters, and we'll start over here with the original Fox DSC. I've gone ahead and cheated, and I have the low speed needle and its housing right here. And for reference, that's what goes through the middle here. This bit here is the same as this part, and then the end of the needle here is attached to this knob here. And so basically it's just a traditional needle and seat where the oil goes in through here and is metered by the very tip of this needle and the profile on it, and then the oil comes out here. So this is very simple and straightforward. This is very common. A lot of compression adjusters work this way, so nothing too interesting there. Then over here we have the Fox DSC Evo, and it's got the same concept where it's just metering free-flowing oil, but they did a little bit different. It's not a needle and seat anymore. It now has a small hole, and the low-speed adjustment mechanism has a varying depth slot in it, and so as you rotate it, the slot is letting less oil flow out. So the oil is coming in through here, and then it ultimately comes out this hole. And if we pull this out here, there's a slot down here, and the depth of the slot changes as it rotates around, and that's what changes the amount of oil that gets to flow through the adjuster. And so it's a simple concept, a little bit easier way to do it, and they've done a good job making it click really well with that. So in the end, they both have similar amounts of adjustment range, and the low speed circuit here is fairly straightforward. Little different techniques, but same performance. So now we're going to talk about the high speed circuit. It's really where the magic is. It's really where the two adjusters are different. And so we're going to start over here with the original Fox DSC. And so the way it works is, again, we had the oil coming through the piston. We had our digressive preload plate here, and this plate is kind of dished in the middle. It's not flat. And so then when the valve stack sits on here and you've got your nut, as you turn the high-speed knob, the nut is clamping down, bending these shims into the plate, and that's increasing the preload on the shims, so it's harder and harder to open those shims up. But once they're open, the rate of change is somewhat similar, and so you get a much higher percentage of low-speed adjustment than high-speed adjustment. And that's also what can create that uncomfortable digressive feeling from the adjuster. And so this is kind of a classic preload adjuster. Sometimes they do these with coil springs. On the DSC, it was pretty creative. They used the valve shims to keep it more compact. But this is a very classic preload high-speed adjuster, and it has kind of the typical digressive fallbacks. Over here, we've got the Fox DSC Evo Adjuster slightly disassembled, and so let's dive into exactly how this thing works. The high speed here is really the heart of the whole thing. And so the fundamentals are oil's coming up through here, it goes through the piston, it encounters a first compression stack, valve stack down here, it's hard to see. Then it has this adjuster plate. Attached to the adjuster plate are these leaf springs. And then after the leaf springs are a second adjuster plate. And as you turn the adjuster, it's rotating the adjuster plate kind of relative to those leaf springs. And so then we'll dive in here and kind of show you what's going on. So this is the rebound check shim right here. So here's the main piston, and you can see it's a progressive piston. And then we have a normal pyramid stack of shims right here. That just sits right on there. And then after that, we've got our adjuster plate here. And you can see the adjuster plate's got this profile to it, which is really important. And then we've got the leaf springs here. The leaf springs are attached to the high-speed adjustment pin here. Those sit on here. And then we've got a second set of shims here. And so the key is this interaction right here between these leaf springs and this adjuster plate. And so they kind of ride on it just like this. And as you rotate it, they're changing where they're interacting with this adjuster plate. So they're starting out with the two tips on the very outer edge here. So there's a lot of leverage over those leaf springs. And then as you rotate it, it's interacting with these narrow points here. So it's gaining a lot of leverage over these leaf springs, and it's increasing the spring rate of these springs. And so that's really a creative and ingenious way of increasing the high-speed compression of an adjuster. And so the couple notable things here when you compare the two is that the DSC is increasing preload by mechanically squeezing the shims more. The DSC Evo is still digressive because this adjuster plate and the second shim stack is preloading the first one. But instead of increasing the mechanical preload by squeezing it more, you're increasing the spring rate of that second valve assembly. And that is increasing your preload force, but not nearly as drastically as it is on the original DSC. And so a little bit later, we'll talk about how that affects the on-vehicle performance. When the DSC came out, it was game-changing for us because it allowed us and for users to adjust the damping externally, high and low speed, which is critical for fine-tuning your suspension. You know, that low speed is really good for G-outs, and some people like to adjust it for handling. And then high speed is really good for adjusting performance through the whoops or speed bumps, things like that. And so just having the adjustment mechanism in there was fantastic. But one of the downfalls was the way that it was preloaded on high speed meant that it could cause some discomfort. And then as you went further with it and you increased the high speed damping, you're increasing preload, which meant it got harder and harder for those shims to start opening initially, which added a lot of discomfort in relation to how much performance you were getting. And so I think that kind of disproportionate comfort to performance is why they came out with the DSC Evo and spent quite a bit of time working on making that balance better. So the DSC Evo here, while it is still digressive, it doesn't have as much preload to it. And when you're increasing the preload, you're increasing the preload force because you're increasing the spring rate, but you're also increasing the high-speed damping at that time much more significantly than on the original DSC. So the DSC Evo mechanism really is better at adjusting high speed than the original DSC was. The other thing that's notable is that the adjuster mechanism does a good job of really backing off that second high-speed valve stack, and so the softest setting on the DSC Evo is much softer than it is on the DSC, meaning it's much more suitable and much more compliant on those lighter applications, especially like the rear of trucks. So the DSC Evo really has been an improvement over the DSC, and Fox has done a great job with the new adjuster. Fox has really done a great job with the new DSC Evo. They've solved a lot of the common complaints with the original DSC. You know, they made the clicks much more defined. They've reduced the force on the high-speed knob so it's easier to turn. They've also done a good job on the performance side of making the softest setting much softer than it had been before. And they also did a good job of managing the digressive nature of the adjuster so that the performance to comfort trade-off is much better than it is on the DSC. So in summary, Fox has done a great job with their new DSC Evo adjuster, and I think a lot of people are going to be very happy with it. If you like this type of content and you want to see more about the adjuster, you can check out an article on our website. We also have a ton of other videos and articles about other subjects like this. So take a look at AccuTuneOffroad.com or browse our YouTube channel.